Hello everyone and welcome to another tutorial video. This one is over an introduction to functions. I put a machine on this video because I think of functions kind of like a machine. You put something into the machine and something will come out of the machine. There are infinite amount of different types of machines out there, so they do a lot of different things. But the main idea is that there is some kind of input and output. Alright, keep that in mind as we continue going through. So we just had this example with this graph, and that's obviously a graph, okay? Output. So basically what that means is that no x values repeat. If you are given a graph, there's something called the vertical line test that you can use to determine whether or not something is a function. Now, this is with a graph, so let's say I have this graph down here. I apologize for that picture. I took a screenshot of my computer, so just bear with me there. So what I have here are toppings versus cost. So if I want to see if this is a function, I could take any vertical line, say this lightsaber here, run it over the graph, and if it only touches the graph, 1 point at every spot on this graph, then it is a function and it passes the vertical line test. So we come back. Get V is a little mnemonic I made up to help you remember the different representations. So G stands for graph. Oops. My little stylus isn't working very well. Okay, graph. E stands for equation. T stands for table. M stands for mapping. And V, I just chose V. You could think of Victor or Vikings if you're a Vikings fan. If not, it's okay. And V for verbal description. Okay, so here's a quick overview of the get part. Again, this stands for graph, equation, and table. Alright, so this all deals with the same function. We're all talking about a pizza and cost and toppings. So as you notice, this graph up here is increasing because our equation here represents an increasing function. We began with 6 of something, and then it is increasing by 50 cents per x. Okay, and then it tells us over here, x is the number of toppings, y is the total cost. So 6 must be referring to dollars, and that must be 50 cents per topping. A table is where you have the input on the left and the output on the right. So if I drew a table of this data, I would represent it the following way. So 0 would be the least amount of toppings that I could have. So at 0 toppings, this pizza would still cost $6. At 1 topping, I would have to take this equation and go 6 plus 50 cents times 1, which would end up giving me $6.50. 2 toppings, I would do the same thing, except this time I would input 2 and I would get $7. Okay, so this would just continue to go up 50 cents every time, but again, all of these are representing the same data. The M stands for mapping. So what mappings are is when the input is on the left and the output is on the right, and these are put into bubbles instead of looking like a table, and they connect to the corresponding pairs. You might also note that in a mapping, on both sides, the numbers go in order from least to greatest. Okay, that's good to take note of because you will want to know that, okay? And also the numbers will not repeat. So if you use a number more than once, all you're going to do is just end up drawing more than one arrow towards it. And the V stands for verbal description. Okay, so here's finally our scenario. Pizza place charges $6 for a cheese pizza and an additional 50 cents for each topping. Okay, so that's the same problem represented by graph, equation, table, mapping, and verbal description. Okay, so here comes the fun stuff. We're going to do some examples. What I want you to do at this point of the video is to pause, then do these examples. So determine whether or not these two ordered pairs are a function, those two graphs are a function, and then unpause the video and come back. Check your answers. Okay, so I hope you went through these problems and were able to do them on your own. If not, let's go ahead and go over them. So this first example, I have this list of 4 ordered pairs. You should have gotten no, because these two x values repeat. So because of that, this is not a function. All right, number 2, this one is a function. This is a yes, because although those y values repeat, it doesn't matter. Y's can repeat as much as they want as long as x doesn't repeat, so yes, this is a function. Number 3, the graph of a vertical line. So let's draw a vertical line on a graph just anywhere. Okay, so if I take a vertical line, try my lightsaber again here, see if that will work. Oh, there it goes. Okay, so I run my vertical line over the graph. Do you see how it is completely over it? What that means is that the line on top is touching the bottom infinitely many times. So is infinitely many more than 1? Yes. So is that a function? No. Okay? Next example, the graph of a horizontal line. So if I draw, let's see if I can draw one. Ran out of room here. Let's see what I can do. I'll make that smaller. Move this over here. Okay, so I'm going to draw a horizontal line. Here we go. And I'm going to run a vertical line over it again. Alright, so is there any point on that line where it will touch my graph twice? No. So is this a function? Yes. Okay, so if you did well, congratulate yourself. If you didn't, then go back and look over the reasons and do these problems again. Alright, last but not least, here are a couple of mappings that I would like for you to try to do. So pause the video here, try to figure out whether or not these are a function, and then unpause the video and come back. Okay, so I hope you were able to figure these out. If not, what really helps with a mapping is if you write the ordered pairs that match to it. So if I have this first mapping on the top, you see how that 2 is pointing to the 7? So what that does is makes the ordered pair 2, 7. Okay? Then I have -3, -4, I have -3, 2, and I have 6, 2. So what happens on this first one? X's repeat. So is this first one a function? No. Alright, second one. Again, I'm going to use the same strategy. I'm writing out the ordered pairs. And I notice that no x values repeat. The y's do again, but again, that doesn't matter. So since the x values do not repeat, then yes, this is a function. Okay, so thanks for watching. I hope this helped. If not, let me know, and I will get back to you as soon as possible. Have a great night.